Industrial facilities, yeah, I don't know. I don't know what happened. But industrial facilities, a lot of warehouses, food facilities, things like that. We see a lot of those used. I don't even remember what that picture looked like. Municipal buildings, we see a lot of well, lately half of my members seem to be working on water systems, water reclamation projects. That seems to be one of the few building types that's still going up these days. But a lot of municipal buildings, anywhere where the tenant's going to be there for a long time and starts to really look at the long-term cost effectiveness of using insulated wall panels, for instance.
I have a question.
Yes?
In the previous screen, the building to the right, these walls are structural or pure architectural?
Right here?
Yes, and the shell...
Yes, those are actually structural wall panels. It's what our industry likes to call a total precast building, which means that it's got precast columns and beams. You can see the double T floors, and then the exterior wall panels are also structural, so they have eliminated all the perimeter structural framing. Office buildings. This is the FBI building in Chicago. So one of the interesting things that we've been doing a lot of research on recently is blast-resistant design. We've been working with the U.S. Air Force on blast-resistant, and that seems to be a hot topic with a lot of government buildings ever since Oklahoma City. That seems to be a key element. One of the other interesting things, this is a building actually in Milwaukee where they took all the cladding off and they wanted to save the office building, so they reclad it in architectural precast, and that's another trend that I've seen quite a bit of. And then a lot of residential, multifamily housing. Not a lot of people are building that this year, but in past years we've seen precast used for that quite a bit. And then transportation products. This is kind of interesting. This bridge here is going over the Des Plaines River on the new leg of I-355, and the beams going across there were 176 feet long. So one of the great things about that is it really shows you how long you can get with precast concrete. They really were trying to be very careful about putting anything into the river and disturbing the habitat of a dragonfly that was there. So they had to have these long beams and not disturb the habitat. And they went to a lot of expense and trouble to create this bridge. And then it turns out that where the bridge casts a shadow, the dragonflies won't fly there anyway. So it ended up kind of being for naught, but it did prove that you can go 176 feet with precast bridge beams. And then probably one of the most common types of products that you're gonna, or projects that you're gonna see with precast products are, can't get it straight today, are gonna be parking decks. You know, that 60-foot long double T, that'll give you, you know, a couple of bays of parking, and you can do decorative finishes on the exterior. You can do simple finishes on the exterior. I just did a seminar yesterday on the history of the parking deck, and it's kind of interesting to see that it's kind of turning. They used to look a lot like buildings, and then for a while they were very kind of simple gray boxes, and now it's kind of turning back, and now they're all looking like buildings again. So that's kind of interesting. So that's really typically where we see it, see the products being used. You guys have any questions about the projects? Okay. Well, I thought I would finish up by showing you a plant tour.
This video will explain the entire process of producing a pre-stressed concrete unit at a pre-stressing plant, in this case, a double T. A double T is used primarily in parking structures, but can be used in virtually any type of building, including office buildings, industrial buildings, and schools, to name a few.
Double T's are kind of a unique product with having a capability of having a very long span. When you start talking long spans, you're talking 60 feet plus, and sometimes goes as high as 120 feet.
The typical day of a pre-stressing plant usually starts very early in the morning. The product from the previous day's casting has cured by now, and the pieces need to be stripped from the form to get ready for today's casting. For any pre-stressing plant, it is very important to maintain a clean plant. Maintaining neatness is not only positive from an image standpoint, but also from a safety standpoint, since any debris that might be left over from the day before could create a tripping hazard or other safety problem. The first part of the process is setting up of the form. A thorough cleaning of the entire form is done with basic labor and appropriate cleaning equipment. Setting the side forms, or in the case of a typical double T, the forms may be fixed forms with an appropriate draft to allow for easy stripping. Once the bed is cleaned, it's ready for setting up today's cast. This particular bed is set up for 5 double Ts, each about 60 feet long. The bed has a total length of 400 feet. This is a self-stressing form, where the form itself is designed to take the total pre-stress force in compression and also to handle the eccentricity of the strands. Sometimes the producer may use a form that is set between bulkheads that are built right into the ground. The pre-stressing force is then resisted entirely by the bulkheads and their foundations. Next, the strands are placed in the form and extended from end to end. Crew members thread the strands through each of the dividers and then run them through the stressing plates at each end. The typical spacing of the strands is approximately 2 inches. This divider is a steel device that separates the individual double T units from one another. A gap of about a foot is typical between the ends of the adjacent pieces. This gap is required so the strands can be accessed and cut, and that each double T can be stripped from the forms. The next step is the tensioning of the strands. In this case, we have a strand pattern with straight strands of 6 strands in each stem, as shown here. The strands are first tensioned to about 2 to 5 kips based on the gauge pressure reading. In this case, a mark is made on the strand after the preload is applied. The strand is then tensioned to the specified level and is measured using the gauge pressure on the hydraulic pump. The QC technician then checks the elongation against the theoretical elongation. The requirement that is the force on the gauge and the elongation must match within 5%. If that tolerance is not achieved, the reason must be established and the strand may have to be detensioned and retensioned. After the strands of this double T are all stressed, the remaining embeds are set in place. These include stem reinforcing, lifting devices that will be used to strip and handle the piece, forms for blockouts in the flange, and forms for blockouts in the stems, flange reinforcing, and flange connectors or vectors along the edges. In this case, one of the double T's in the bed has typical flange connectors applied along one edge and special flat plate connectors applied along the other edge to accommodate connections across an expansion joint. The form is now ready to have concrete poured, but only after a pre-pour quality control check has been made and the QC person signs off on it. This QC check can also be done by the bed superintendent and depends on the particular plant's practices. Either way, the check is critical to ensure an end product with the highest quality.
There's all these things you look for. The mesh, you look for anything that could be touching the stems on the bottom, like any wire ties that might have fell in there because that would develop some type of a rust spot. You check the length. You want to make sure that the dams are correct. Do we have the strand stripped properly? So there are a lot of critical areas that you need to verify.
Concrete is mixed at the batch plant under tightly controlled conditions. The cement is supplied using tanker trucks. Here, the cement is being blown from the tanker through piping to the cement silos. When needed, aggregates are delivered to bins in the batch plant. The aggregates are stored outside of the batch plant in separate bins. In this case, an enclosed vertical bin system is utilized. During winter, in northern climates, the aggregates must be heated to get them to flow properly through the batching system and to maintain proper concrete mix temperatures. Payloaders are used to shuffle the materials to the conveyor belt.
Well, lately, half of my members seem to be working on water systems, water reclamation projects. That seems to be one of the few building types that's still going up these days. But a lot of municipal buildings, anywhere where the tenant's going to be there for a long time and starts to really look at the long-term cost effectiveness of using insulated wall panels, for instance.
I have a question.
Yes.
In the previous screen, the building to the right, these walls are structural or pure architectural?
Right here?
Yes, and the shell.
Yes, those are actually structural wall panels. It's what our industry likes to call a total precast building, which means that it's got precast columns and beams. You can see the double T floors, and then the exterior wall panels are also structural, so they have eliminated all the perimeter structural framing. Industrial facilities, I don't know what happened. But industrial facilities, a lot of warehouses, food facilities, things like that. We see a lot of those used. I don't even remember what that picture looked like. Municipal buildings, we see a lot of office buildings. This is the FBI building in Chicago. So one of the interesting things that we've been doing a lot of research on recently is blast-resistant design. We've been working with the U.S. Air Force on blast-resistant, and that seems to be a hot topic with a lot of government.